We're continuing with the topic on calculations, and today we're going to move on to the mole. So, what is a mole? In chemistry, a mole is simply an amount of substance. So just like the way in the English language, you can say, I have a dozen shirts. That would mean you have 12 shirts. A mole will simply represent Avogadro's number of particles. So that's a big number. It's 6.02 times 10 to the 23. So if you look here, the official definition is that a mole is an amount of a substance that has as many particles as there are in 1 mole of carbon. Now, 12 grams of carbon-12 is 1 mole. So that's the definition. Avogadro's constant is there, 6.02 times 10 to the 23. So you can see that's much bigger than a billion. It's a huge number. Now, the reason the words ions and molecules are mentioned is that you have to read very carefully the question, and I'll show you exactly what that means in a minute. But simply put, 1 mole is equal to the MR in grams. So remember in the previous lesson, we did MR, where you add up the relative atomic masses. Well, 1 mole will equal the MR in grams. Here are a few examples. So carbon-12 has a relative atomic mass of 12. So 1 mole will have a mass of 12 grams. Similarly, aluminium has a RAM, relative atomic mass of 27. So 1 mole would be 27 grams. And the last one, sodium hydroxide, has an MR of 40. So 2 moles would have a mass of 80 grams. Now, the mole in this kind of aspect that we're doing now is not really examined that much, maybe 1 or 2 marks. You mainly have to be able to apply the formula. But I will teach you this because you should have an idea of it. So let's consider the mole a bit more. If we look at the bits in red, 1 mole of carbon atoms will contain that many carbon atoms. 1 mole of water molecules will contain that big Avogadro number of water molecules. And similarly, 1 mole of chemistry teachers will contain 6.02 times 10 to the 23 chemistry teachers. So let's look at that in a little bit more depth now. Let me open a blank sheet. There we go. So make this nice and big. Let's write it down. What does this practically mean? If I write it down here, so if I have 1 mole of H2O molecules, okay? Now 1 mole of H2O molecules would equal 6.02 times 10 to the 23 molecules. The question is, how many atoms would it equal? So 1 mole of H2O molecules, how many hydrogen atoms will there be? And how many oxygen atoms will there be? Well, if you consider 1 mole of H2O contains 2 hydrogen atoms. So that means 6.02 times 10 to the 23 has to be doubled, would be doubled if you're looking to find the number of hydrogen atoms. But if you're looking to find oxygen atoms, then you do not need to double it, because for every 1 mole of H2O, there's 1 mole of oxygen atoms. So once again, for every 1 mole of H2O, there are 2 hydrogens, but for every 1 mole of H2O, there's 1 oxygen. So this is the difference. Okay, obviously you can double that on the calculator and it'll give you something like 12.04 times 10 to the 23. That's not important. The important is the principle. So that's a covalent molecule. Let's consider, if you change that to 2 moles, by the way, 2 moles of water would contain 2 times this molecules and would therefore contain 4 times this hydrogen atoms and 2 times this oxygen atoms. So you would double everything if that changed to a 2. Now, if you consider something like aluminium oxide, and you consider that you have 1 mole of this, then that would mean that you have 6.02 times 10 to the 23 formula units. So you cannot say molecules because it is ionic, metal and non-metal. So you would say there's 6.02 times 10 to the 23 formula units of aluminium oxide. That would be a true statement. You could also say that there are 2 times 6.02 times 10 to the 23 Al3 plus ions, because you can see for every 1 mole of this whole formula unit, there is 2 Als. Aluminium is in group 3 and has a charge of +3. And lastly, well, you might have guessed it, there'll be 3 times 6.02 times 10 to the 23 oxide ions, because there's 3 in every one of these. Now, obviously, if you manipulate this number, you would then have to times these by whatever you times this one by. Lastly, you should be aware that Avogadro's constant has the following units, which are mole minus 1. So if you're looking to find the number of something, you would simply need to do this multiplied by the moles. That's what we're effectively doing, because these cancel each other out. So that's essentially what you're doing here. Okay, you're timesing it by 2 moles. So you're canceling the units, because obviously mole to the minus 1 is 1 over mole times mole, they cancel. So in the question, if someone was to give you as a final example, calculate, they could say to you, calculate how many, let's see, calculate how many water molecules there are. So how many water molecules, notice, which refers to the whole H2O. How many water molecules in, I don't know, let's make it up, 50 grams of water. To calculate this, you first find the moles. Now, for this, you will need to use the formula that we're actually about to cover. If you have already worked it out, it is actually that the mass has to be divided by the MR, but we will be doing that next. But I'm just showing you that 50 divided by H2O, H2O is 18. That will actually give you how many moles of water you have. Because remember the principle is that 1 mole of water will contain the MR. So 1 mole would actually equal 18 grams. So we're looking at 50 grams. That's why I'm doing 50 divided by 18. I'm trying to figure out how many moles of water I have, because 18 grams will be 1 mole from what we've just done. So 50 grams will be how many times is the 18 multiplied to get to 50? And then that would be moles. Then you would times it by mole minus 1, which is Avogadro's number, like this. Then you will get the number of water molecules. If you're looking for the hydrogen atoms, you would then have to double this whole thing, just like we doubled this. So I hope that makes sense. But as I said, this is not really something that's tested that much. What's more important is that you know the formula and how to apply it, which is our next bit. We shall just save this very quickly. Okay, let's move on now. Let's look at the mole formula. So the formula for moles is as follows. 1 second. Here we go. So the formula for moles is that moles equals mass divided by MR. And the abbreviation on in the top right that you see is N equals M over MR. So don't confuse, moles is represented by the letter N, not the letter M. So N is the moles, little m is the mass, which has to be in grams. So if they give you kilograms or tons or milligrams, you must change it to grams, otherwise it's wrong. And then MR is what you get by adding up the relative atomic masses from the periodic table. So don't worry that the units are G per mole, but that's what they are. If you think about it mathematically, let me show you. The grams divided by grams will cancel. And then you get 1 over 1 over mole, which gives you mole. That's how it actually works. Now, for some of you that prefer a triangle, I will show it to you in the triangle format too. So let's have a look. Here we go. You can use this triangle if you prefer. But remember, this is the most important formula in the whole of chemistry. You'll need it in your A-level, in your GCSE, and is this one here. So N, which is moles here, is mass, which is little m, over mR in the case of a compound, and AR in the case of a element. That's the difference. But that's just a technicality of the language. Just remember that it has to be in grams. Now, if you were to rearrange the formula, then mass will equal moles times mR. Another very, very important point. And lastly, if you want to rearrange it to find mR, then mR would actually equal mass over moles. Now, if you're not particularly strong at maths, you can just use the triangle by putting your fingers to one side and then applying it. We shall now look at some examples of how you find the moles and look at the beginning of the worksheet. Then you will practice the rest on your own. And then that's how you do moles. If I scroll down, I'll go over these. Then I'll be looking at these questions in the next lesson. But for now, we need to apply the formula for moles. So it says, how many moles are there in 1.7 grams of ammonia? Well, the formula is mass over mR. So moles equals mass divided by mR. The mass is 1.7, and the mR of NH3, using your periodic tables, make sure you have one handy for this topic, along with a calculator. Nitrogen is 14, and hydrogen is 1, and it's 3 of them. So 3 times 1 plus 14 makes 17. So we get 1.7 over 17, which will give you 0.1 moles. And that's how you find that. On the other hand, if they ask you what's the mass and they give you the moles, then you use the rearrangement that mass is moles times mR. So if the moles are 0.25, you write 0.25 times, then the mR of water, oxygen is 16, again from your periodic table, and hydrogen is 1. So 2 times 1 plus 16 is 18. So you just times these two together, then you put 4.5 grams. Units are important for mass. They're not important for mR, and they're not important for moles. So you don't actually have to write mole. Okay? That's the one time you don't have to. Now I'm going to just go over 2 more examples from the worksheet. Then you would try the rest on your own, and there'll be answers provided. So if I do, say, B, find the moles, 3SF. All I do is I write moles equals mass over mR. I'm not a fan of the triangle. My mass is 20. Then my mR, carbon is 12, so it's 12 times 4. Hydrogen is 1, so it's 10 times 1. So you get 48 plus 10, which is 58. And then the answer would be 20 divided by 58. If I just, for the sake of completeness, get you the answer. 1 second. Yes. So 20 over 58 would equal 0.345. And then that's done. Be careful. Here, here, and here, you must change it to grams. So 10 to the power of 6 grams equals 1 ton. So that's 1,000,000 grams. 1,000 grams equals 1 kilogram. And this is the weird one. 1 gram equals 1,000 milligrams. So you have to divide that one by 1,000, times by 1,000, times by 1,000,000 to turn into grams. Okay, lastly, just to show you how to do mass, one more example. Calculate the mass of the following. I'll do this one. So mass equals moles times mR. Moles is 0.1 times mR of this. So hydrogen is 1 plus, nitrogen is 14 plus, oxygen is 16. 16 times 3 is 48. So 48 plus 14 plus 1. So that is going to be 263. The answer is 6.30 grams if we're doing 3SF. So try the worksheet, get used to finding moles, because moles is the first step in what I call the 3-step method to find reacting masses and loads of other things. So you must know how to find moles. So practice it well and check with the answers provided. See you next time for the reacting mass lesson.